So the mean is 125. 127, I don't know precisely where that's going to be, but I know it's got to be, if I'm counting in terms of standard deviations equal to 1.2, it's got to be a smidge less than 2 standard deviations away from the mean. So I'll just kind of mark it off here. This one would be 126.2, and this one would be 127.4. That's just because I'm counting by 1.2s. I'm taking my mean and adding 1.2 to it, and then 1.2 to it again. Since my benchmark here is 127, that's, I can't obviously mark it exactly, but I can give a sense of where it is. All right, and I want to be greater than that. Greater would be to the right, right? So area to the right of that location. All right. Again, I only do this. It's not a requirement. It used to be a requirement for me. Just, I don't know why. I don't have an explanation. I used to make people do it. Kind of force you to have something to sort of check your work. I like to do it because I have a sense going into the problem what my answer ought to look like. So I know that I'm looking for something that's going to be less than 0.5 because I didn't shade half of the graph. Actually, it might even be less than like a third. Something in the neighborhood maybe of a third. But at least I have a sense of what my answer ought to be. All right, so I'm going to do a normal CDF. Because I'm looking for the probability that I'm going to get an X value greater than 127. I need to go from 127 to something large. And you put in whatever large number you want. We do it once and then another time to see if there's any difference in the decimal. But you don't have to actually tell me what the large numbers are. All right? So I just write 127 to large. 125 is the mean. 1.2 is the standard deviation. Wrong thing. That's not the calculator. So second bar's option 2, 127. I'll put in something that I think is large. I'll put it in 1,000. The mean is 125. And the standard deviation is 1.2. So I get this. And then I'll just do it again. Second enter. And then change my 1,000 to anything. Anything larger or smaller, doesn't matter. I like to go one larger. And see if there's any movement on my decimal. That's how I know I've gone large enough. If there is movement on your decimal, then you want to go even larger. All right. Now, interpretation is something we'll focus on in this unit. It's not really calling for it in this question. It's more so about the skill. But I do want to talk about it for a second. The interpretation of your answer comes really down to whether or not you have a sense of the mean and standard deviation, right? So we're talking about IQs. I don't know what like good and bad is anymore. I know it used to be 100 was average. Then there was some number that if you were over that number, like 135, I don't know, 130, that you were considered a genius. But it could be even higher than that, so it may be like 150, I don't know. But what this is telling me, regardless of what's good and what's bad, is that we have a group of individuals, and actually it'd be kind of funny if it's a bad number, because then it's like, yeah, I knew it. I knew all my math teachers were stupid. So 125 with a standard deviation of 1.2 is telling me that I have a group of math teachers, all with a average intelligence quotient, that are separated by a very small amount, which means that their intelligence quotients are all tightly grouped. So they're all in the same neighborhood as one another. To equate it to scores like in a class on a test, That would be like saying, and let's assume the 125 is good. That's like saying that the class average is a 90 and the standard deviation is 2. That's telling us that we have a tightly grouped set of data around 90. Now, a lot of people will walk away saying the overwhelming majority of students had a grade in the ballpark of 90. All right, and so that's what this is telling me, is that the overwhelming majority, or even more than that, like almost all of math professors would have an IQ in the neighborhood of 125, all right, plus or minus a couple of points. So, part B, that's where it becomes CLT, central limit theorem. Now we're getting groups of 75. All right, so the setup is the same. I would draw pretty much the same diagram. I mean, it would look different based off of my standard error, but what I put into the calculator, what I would write as my probability question would be probability that X bar is greater than 127 instead of X, but it would be normal CDF 127 to something large, comma, the mean, comma, the standard error, which would be 1.2 divided by the square root of 75. All right, because again, this is mu sub x bar, and this is sigma sub x bar, which is the same as sigma over the square root of n. All right. So what's the difference? Well, the clear and obvious one is that I'm not taking a single math professor anymore. I'm taking groups of math professors. I'm not just taking their individual scores, I'm taking the average score. So what I would be doing is comparing groups, a group of 75 against another group of 75 against another group of 75. So when I find the average of all of those groups, it's going to be the same as the population average, population mean, but the spread is going to be much smaller, right? Even though it's small to begin with. Because what's going to happen is if I take the average of a particular group, I'm eliminating any extremes. So, yeah, I have an average of 125 normally, but the reason there is a standard deviation that's positive is because there is some spread. It is possible that you have a very, very below average person that somehow became a math professor. Maybe you have somebody who's, I don't want to say overqualified, because intelligence doesn't always lead to qualification. I mean, we've all been in a classroom where it's like, wow, teacher is incredibly smart. If only he could learn how to explain to us what's going on in his mind. AKA, he understands, he's smart, he's good at math, he's just not good at teaching the math, or she, you know. So intelligence doesn't always relate necessarily, but I would imagine it's a pretty solid component. Anyway, all of those extreme values would be eliminated. Right? You come up with one number that represents the average of that group, and then you compare that to other averages. Naturally, there's going to be less variation. Right? There's going to be less of a difference from one group to another. It's kind of like if I were to compare this stat class to another stat class to another stat class to another stat class. I'm not going to give a list of all the grades of all the students in this class. I'll give the average grade. So I'll have a single number. I can't imagine that single number is going to be too incredibly different from Professor Simpson's single number, from Professor Pretorti's single number. You know, they're all going to be somewhere in the same neighborhood, right? I mean, mine will be better, but, you know, it'll be pretty close. You know, it'll be right in the same stratosphere, but, you know, I actually named those two because they're pretty good. My sister actually had Professor Pretorti as a teacher, and she said he was great. Oh, there's two of them, I forgot.
What was 140.
What's that?
140 is the limit for genius.
140 is.
Where it starts.
Huh. So let's look at that in a second.
It's your ultimate graph where you're maxed out. So,
So the only adjustment I have to make is to make the 1.2 into 1.2 over root 75. So that's good news from a student standpoint. It's like, okay, so I just got to look for some keywords. Got to change a thing, a single thing. I was going to say a thing or two, but not even a thing or two, just a single thing. And then you get the answer. I sure would like for you to understand why you got that answer, but for now I'll just settle for you getting the answer. All right, and also you look at this. This is an incredibly small number, and it's also a good learning opportunity because when you get an answer like this, you have to be very careful about how you report it because I've had people write 1.659 down on a piece of paper, write that as their final answer and call it a day. That's a 2-point deduction if you do that. 1, because you made the rounding mistake, and 2, because you demonstrated a lack of content knowledge, which is basically, there's a difference between like, you know, a mental error and like a physical error in sports. In math, I look at it a difference between like a careless error and a conceptual error. Like a little minor algebraic error, not a big deal. One that demonstrates that you don't understand a concept, that's a big deal. Okay, so if you write 1.659 down as your final answer, what that means to me is that you didn't recognize that this answer is supposed to be a probability, and that probabilities can only exist between 0 and 1. So it's automatically a red flag if you write anything more than 1 down on paper. All right, so just be careful about that. This E, negative 47, that is what makes it an acceptable probability, because that's our scientific notation. That's telling us that if we move this decimal over 47 times to the left, so 1, 2, 3, 4, 5, total of 47 times, you'll get the true decimal, which I obviously wouldn't want you to write, because that requires you to write 46 zeros and then 1659, blah, blah, blah. So just write the entire thing that I highlighted.
It's also the same reason why you don't take that last number and get a solution for it. So if you put in a calculator 1.2 over square root of 75, you get 1.39 blah blah blah. I mean 0.139. Whatever. It comes up with a whole different number when you do it.
Because of the rounding component. Yeah. The slight differences in rounding will throw you off completely. All right, so you got to be very careful. Now, this is basically saying virtually 0. All right, so if 140 is the benchmark for genius, what this is saying is that the probability that I would get a group of people whose average intelligence is more than 127 to a group of 75 people is virtually impossible. I mean, that would make sense, right? But I mean, I didn't even use the genius level. Like, I'll just say pretty smart, right? The idea that you could take 75 people or 75 groups and have an average, yeah, there's got to be some, I don't know how to put it. There's probably a nice way to say it, but there's got to be some dumbasses in there, right? Like, there just has to be, you know? Yeah, and again, also, just to make sure I say it, intelligence quotient, yeah, there's that, but then there's also other aspects that makes a person into a success. So, you know, you might not be a genius level intellect. I think at one point I was, but Then I turned like 9. So, and then I stopped giving those little quizzes with the circles and the squares and patterns and stuff. I don't think that's an accurate representation anyway. I had a certificate at one point, but yeah, it's not the kind of thing where I'm being invited to like Mensa meetings or anything. So, yeah, but let's see, because that was something that I became interested in once I heard it. What would be the probability of having, let's just go with even one person being on the genius level if we're defining genius as 140? And that sounds like it's a reasonable enough number. Virtually impossible. So then, I mean, I don't even want to write that. It's going to be in the same neighborhood as this, but imagine trying to take that and get 75 people, a group of 75 people that we would all consider to be geniuses. The calculator is saying, yeah. It's saying, nope, not going to happen. Now, that's not the calculator saying that it is exactly equal to 0, therefore impossible. It's not mathematically impossible. It's just so close to 0 that the calculator can't distinguish it from 0. So it might as well be 0. The other one is like, it's the whole Dumb and Dumber. So you're saying there's a chance business. This is more like, no, there's no chance. There's no chance whatsoever. But like, just use your common sense. If it was like 0.000000000000000000386. I missed the 0. Chance of being a genius using this information, then the fact that you're going to get, for one person, how are you going to get 75 people together on average to have an intelligence quotient above 140? It's just not going to happen. But common sense will tell you that too. All right.